Okay, today we'll definitely finish about the Java version for the decide by contracts. And really the main purpose is we want to show you can definitely implement decide by contracts somehow in Java. It's just not as convenient as the language we're going to use for this course. But let's talk about the final version we're going to reach. So this is the second last version that we talked about. Let's briefly review what we got from this one. So far we talk about preconditions using exceptions. We talk about specifying class invariants using assertion in Java. Now, the only thing left is about how to specify postcondition for your method, which is turned out to be the more complicated one among the three to specify. And starting from Wednesday, we'll talk about how you can write complete postcondition in iPhone on Wednesday. That'll be the subject. But for today, let's see, just get a feel how you can write about postcondition. Okay. Let's look at this particular version over here. That's version number 4. Okay, you can see that we got precondition over here for the withdrawal, right? So these are the two error conditions over here. And now let's have a look at this particular part I'm highlighting here. So this implementation here is apparently wrong, right? Apparently it is a mistake by the supplier. However, if we just try to execute this block of code by using it, it's not going to report any kind of violation for the contract. So there's something wrong for the design. Okay, again, you can see that over here we have, rather than minus the amount, we got plus the amount. That's wrong. And by the way, this one here is the invariance that we talked about last time, the class invariance. Okay, let's now see how wrong it is for the version number 4, and then move on to the last version to see how we can resolve it. Okay, so now for version number 4, let's say we have a client over here. Let's say we are initializing an account with the balance 100, okay? Let's now, whenever you want to talk about postcondition, you want to talk about the states for the attributes before the method call and the state for the attributes after the method call. That's something you want to really see, okay? So now let's say so this is line number 7 we're talking about. So we talk about before we try to execute line number 7, and after we try to execute line number 7, okay? Before and after. So now, for this particular example, before that, we know that the balance is going to be, well, 100, right? It's going to be just 100, the initial one, okay? According to the current implementation over here, which is wrong, when we say withdraw 50, rather than having minus, it is going to do plus, right? So what it would do is, it's going to say after this particular method call, the balance will be 100 plus 50 rather than minus, right? So that's why we'll get 150. Okay, so now we basically got two values for the same attributes for which we can compare to actually somehow specify what should be the correct behavior, okay? To be more precise, you can see that let's say the green one is the before value, and also the orange one is the after value, right? So somehow we want to say the after value should be the before value minus the amount rather than plus, right? Apparently we are violating that. However, currently there's no such check for us to actually check it to make sure this particular postcondition is satisfied. So what you will see is, you can see that initial balance is 100 if you try to run it, and then it's going to tell you it's actually simply 150. Well, apparently that's wrong. Okay? That's where we worked last Wednesday. Okay? So what we're going to do, we're going to introduce a final concept for decide by contracts called postcondition. And as I briefly mentioned last Wednesday, this is the most complicated contract for you to write compared with invariants and compared with precondition, because you always have a notion about before and after. You always have to draw a relation between the before and after states, okay? We only talk about simple example for this one here, but we'll talk about from Wednesday the much more complicated one for postcondition, which you will do for lab number 2, okay? So hopefully we'll just cover that in time for you. So now, this is version number 5, okay? Oh, actually before I show you the Java code, let's go over some concept. What's really postcondition? Okay, postcondition basically you want to specify upon the completion of your method what should be achieved, okay? And, okay, it relies on, okay, so basically the before and after states, you can read it through. So let's just have some idea about what the postcondition can be. Let's say for this, We talked about the same method previously when we talk about preconditions, right? We say that the precondition for divide should be y should not be 0. So we don't have division by 0. What about the postcondition over here? First of all, I'll give you a little bit hints. Because we have an accessor method here, or in the IFO sense, query, which means the method here is going to return something. Okay? Let's say we can call the return value to be result. Okay? It's a keyword in IFO. How can we specify the postcondition for this? Okay? Let me just switch to iPad over here. Okay? So now let's talk about the postcondition here to get a feel. Okay, so now let's say we have divide. Oops. Okay, let's just make integer, just simplify every matter, okay? Let's say we can always divide evenly, okay? Just make it, we don't have any remainder, let's say. Divide, we got integer x, and also we got integer y, okay? So what we want to do, let me just show you a little bit IFO, we want to say ensure, right? So now, somehow, in the post condition over here, how do we specify that? We want to specify a relation between the result over here. So you can definitely use the result keyword. So that's the return value. So what should be the relationship between result, x, and y? In this simple case, yeah? Yeah, well, that's true, right? Well, that's kind of like a division. You're trying to define that by itself. You're getting close. Yeah, I like that. Which means result multiplied by y should be equal to x, right? Oh, by the way, this equal sign means mathematical equality, right? Doesn't mean a sign. So this is a post condition for you. Okay? Are we okay with this? So this one tells you two things, which is very common to have, mistake to have. Every time in IFO, I'm looking ahead a little bit. Every time if you're trying to specify a post condition for a query, which means a method that returns something, you always have to use the result keyword as part of your post condition to say, how do we constrain the value for the return value? Okay? It's a very common mistake. You simply don't have that. Okay? That's the very first one. I do have some interesting one for you to work, for us to work together. But let's get some intuition first. Any question about this one here? Okay? What about the post condition for binary search? This one is a little bit more interesting. Mm-hmm. We know that the result in this case is going to be either true or false, right? Either true or false. Now, how do we specify the relationship between them? Okay, let me write it down. You can think about it. So basically, we have Boolean over here, and we have binary search, and then we got integer x, and also integer array xs. Okay, and now how do we specify the post condition for that? Mathematically speaking, okay. Thinking this way, what does it really mean when result is true? That means the item that we're looking for is in there, right? What if it is false? That means it is not there, okay? So now, how do we somehow to say the following? I know that result, which is a keyword, can be either true or false. The truthfulness for result is going to be equivalent to some predicates on the array. Okay? Now, let me give you a little bit hints. What about existential quantification?
You can say like result is true if and only if there exists an I between 1 and xs.length.
Yep.
Such that x specifying equals that.
Yeah, exactly. That's exactly right. Very good. Okay, I'll write it down, and then we can see that's exactly right, what Ken just said. Okay, it's going to be equal to the following predicate. There exists some I, dummy variable, and now translating the IFO for you, just for your information, such that, let's say, let me just use Java term. Let's say start with 0. Okay, let's say 0 less than or equal to I, less than xs.length. Okay, it is the case that xs at position I is simply the same as x. Okay, are we okay with this? It's a very practical application for what you learned in 1090. Okay? Are we comfortable with this? Okay, question, yes. Oh, actually, this is my, I'm not sure, you might have slightly different syntax for your 1090, so this is how I write it. When I say there exists some dummy variable such that, okay, so over here I'm specifying the range for the dummy variable. And when I put a bullet point, I'm saying it is the case. Which means if the range is satisfied, the property should be true. Just a one notation, okay? You don't need to write it, you just need to read it, okay? At least you are in my class. Just make sure you can read it. So now, how about we translate it into iPhone? And we did it once for the for all, and we do it again as a practice for you for exists. Basically, you still have to use the across syntax. Now, rather than say across something all, we're gonna say across something some. That's kind of the keyword you gotta change, okay? Let's write it. So this is math over here, okay? The one, I'm just gonna box it in pink. Oops. Again, you gotta convince it you're really trying to draw a rectangle. Good. Now, let's see how we can do it in iPhone. I'm gonna write it in green, okay? Basically, you're saying the following. Still, we have result over here, which is a Boolean is equal to, okay? Something over here, okay? I'm gonna put it like that, okay? Now, how do we write it? Every time you want to do quantification, use across. You're gonna say across over here, across, and then we have some integer interval over here. It's gonna be from 0, vertical bar, dot, dot, vertical bar, right? We talked about it last time. And then we got s dot length minus 1. And one thing to note, the compiler will be much happier if you put a parenthesis around. Otherwise, you got compile time error. Every time if the lower bound or upper bound happens to be some expression, make sure you bracket them, okay? Okay, from this to this, s some I, right? Remember we said before, I is an integer cursor, right? You can watch a recording to see exactly what it means. And then now, because we talk about existential quantification, rather than using all, we're gonna use some. Some over here, okay? And then some, and we can translate just this part. It will be very straightforward. XS, and now the only thing you gotta make sure is in math, I is just the dummy variable value. But here you're gonna say, whatever value that's being pointed to by the integer cursor. So you're gonna say I dot item over here, and then is equal to X. And that's iPhone. Okay? You can see that the correspondence is quite high, right? It's pretty much corresponding to it. So that's the advantage for specifying the contract precisely in the context of iPhone. Okay, any question about this before we talk about one more postcondition together? Okay? Well, I have a question for you. Page below. Okay, so now let's talk about this example here. Let's say I want to have the following mutator method. Let's say I have void over here. Okay, let's practice both precondition and postcondition together. Okay, and I call it void, and then I would say, and then I would say integer I for some index. Let me write it this way. I have some integer array over here. Let's call that XS. I have some integer index. I call it I. And then I have another integer called it X. Okay, that's the mutator method I'm defining. Okay, let me explain to you how it is supposed to work, and then work out together what the precondition and postcondition is. Okay, this is how it is supposed to work. If I try to call the following, let's say XS is now pointing to this particular array. Okay, let me make it very precise for you. Let's say indices 0, 1, 2, 3, 4. Okay, let me put some integer over here. Let me say 23, 46, minus 23. Let me say this. Let's say 16 and 20. Doesn't matter. Okay? So now let's say one example over here. If I say, forgot to give a name for the method. Okay? So it's going to be void. And then I'm going to say, let's say change. Just say change. How do I change it? So if I call change over here, and then I will pass maybe XS, and when I say maybe index 3, and then let's say I want to change it to, let's say 105. Okay, what does that mean? Okay, that simply means I want you to go to this particular array called XS, and then go to this particular index over here and change its contents to 105. Okay, very easy method. Okay, basically you want to change a particular index of the array to some elements, to some number. Okay, that's what we are trying to do here. Now we want to write the pre and post conditions for them. Okay, let's write the precondition first, the surface condition, not the exception for which you're going to throw the exception. No. Okay, the precondition is easy. When I say require over here, okay, what should I do? Precondition, yeah. Yes, you talk about not being null, right? But remember, in IFA, we'll talk about void safety. So you can assume XS, according to your lab number 1, is non-detachable, which means it cannot be void. So let's not worry about it.
It's required that I is inside.
Yeah, it's a valid index, right? Let's talk about in Java sense, right? Okay, so what we can have is, you can have, let's say over here, valid index, you can say 0 less than or equal to I, and let me just go back, I'll just n, okay? And I less than xs dot length, for example, right? It's only a matter of syntax, so you can get used to it, right? The idea is really important. Okay, that's a precondition, right? And x can be any integer, and I here can be any integer, right? For example, over here, if I simply give you, for example, 5 for the index, there's no index 5 for this particular array. So we're going to have some precondition violation, right? Okay. Yeah, question? The length would be where? Okay. No worries, no worries. Okay. So now the post condition is going to be more interesting. Okay. Now, how do we specify ensure over here? So here, I'm not concerned about, let's say we are the clients for this particular method. We're not so concerned about how the supplier is going to implement this method. We're only concerned about having a contract to constrain the supplier, right? So now for the ensure, how would you write it? You want to be as complete as possible. Complete in the sense that you want to cover basically every element in the array and say something about them. You can think about conceptually, you got XS before change and after change. So how exactly are the two versions going to be different? And we'll learn about exactly how to specify this on Wednesday, starting from Wednesday. But today it's only just the field. Right? Anyone want to try? Yes. Just give me one. Okay. Yeah, exactly. Since we know that the precondition is is a valid index, so we can assume that, right? That's the benefits for the supplier, right? Okay, I agree with you. So what I would do is I would do one thing here. I would say you can give a tag to post condition. I'll say changed. Okay, it's a tag, and then I would say XS at index I is really now equal to X. Let's say this. Let's say I only got this post condition over here. Do you think it is good enough to constrain the supplier? If you don't think that's good enough, give me a scenario where the supplier does something bad, but it will not really trigger a post condition violation. Okay, say it again. Oh yeah, exactly. Basically what you're suggesting is, what about we change everything else except for this particular index to 0, for example, right? Let's try that, for example, right? So now let's talk about conceptually, let me just redraw the array over here, okay? So let's say this is the array before and another array after. So this is XS, I would say the old version, okay, conceptually. And then we got 23, 46, minus 23, and then 16. And then 20, right? And the method call that we are trying to do is this particular one. Let's keep it the same. Okay, we want to basically modify index 3 over here. Okay, let me just put the index here. 0, 1, 2, 3, and 4. We want to modify that to 105. Let's say this is the new version. Okay, I'll say new. Okay, there's no new keyword, by the way, in IFO. I'm just saying conceptually it's new. Okay, okay, let's say we got basically the same array of the same size. Let's say 1, 2, 3, 4, 0, 1, 2, 3, 4. Okay, let's say we did change it to 105. Let's say. So that means we did satisfy this particular post condition over here. However, we claim that it is not enough. What if the supplier somehow default all the values over here to be just 0? Apparently, this is not right. But as far as the post condition that's already listed here is concerned, you cannot catch that. So we say that your post condition is not complete enough. So here's a guiding principle. Every time when you're dealing with a change to some data structure, let's say a tree to an array or linked list, not only that you want to make sure the part that you intend to change has been changed, but also the rest of the data structure remain unchanged. Okay, that's kind of the lesson here. So now what we want to do is we want to add in another post condition which presumably is going to worry about what about others. Let's say all the other indices rather than I. What happened to them?
You say it's like for j from 0 to I minus 1, and
Uh-huh.
from I plus 1 to x
Sure.
dot length,
Mm-hmm.
xs of j equals full x.
Something like that. Okay, absolutely, I'll write it down. Okay, I like that. Okay, not exactly what I'm thinking in my mind, but I'll write it down first. Okay, how about I write down his version first, and then I'll take your maybe kind of yeah. That's right. That's maybe the second version I'm thinking about. But I'll put both versions for the sake of class, right? It's good to learn from both. Either one is fine. Okay. So now what I will do is, okay. So everybody kind of know what the issue is. So what I will do, let me just isolate this a little bit, and then I'll put another new page. And then we'll talk about. Okay. This is what we got so far. We're going to add in one more post condition, okay? I'm going to call this, let's say, others unchanged. Okay, over here. So what can we do over here? Basically, what we have is, you can say, for every I, such that we're going to exclude the value for I, right? We're going to exclude it. Okay, for maybe it's better to use a different dummy variable, otherwise you get confused. Let's say j. For every j, such that it can be 0 less than or equal to j, less than I, or I plus 1 less than or equal to j, less than xs dot length. Right, we'll talk about two possibilities, right? You can either all the left indices before I or all the right indices after I, okay? It is the case that we have xs j over here is the same as old xs j. Let's talk about this version first, okay? And then we'll talk about the second version, okay? I'll illustrate that to you. Okay, I will help you parse this a little bit better. If you can look at this way here, and there's a disjunction in between. Okay, before that, let me just, to save my drawing, I'm gonna copy this part of the code, no, not code, the drawing. I believe I can do that. Okay, but I'm gonna erase, okay, just that'll be fine. Okay? Yes?
Would it only work if the array length is odd?
The array length is, let's talk about array length a little bit later. Let's just focus on this first. Okay, yeah. Okay, so now let's talk about this one here. So basically, we say that over here, for this particular case, we know that j, let me just put on the method call again. So we talk about change, and then xs And let me just copy that. It's going to be 3 and 105, right? 3 and 105, right? Basically, we talk about two different ranges for j, right? It's either before I and also after I, right? So basically, we're saying the following. Let's say, what can be the possible value for j over here? What can be the possible value? Well, you can see j is going to be, in this case, I would be 3, right? And also I plus 1 would be 4. So that means j would be from 0 to 3, which means it's 0, 1, and 2. So 0, 1, and 2, right? Right before that. And also, it can be from 4 until x dot length, or it's actually less than x dot length, right? The length would be 5, so that would be up to 4. So that means we only cover 4 here. So these will be the indices for j to iterate through. Okay, guys, are you okay so far, right? It's only about tracing it, okay? So now we are saying the following. For every such value for the j, it must be that the old version for this expression over here must be the same as the new version for that. For example, in a case where, let's say, j is equal to 0, for example, in that case, the old version is over here. The new version is over here. 23 equals 0, false. So that means this predicate over here just cannot be true. Okay, it's going to cause some violation for the postcondition. Okay, are we okay with this? Yes, question.
What if you, let's say we change 4 like index 4. What would that become? That would be like 5 less than equal to...
You mean if you change the...
Yeah, let's say 3 and 4 is 4 and 5.
Oh, you mean over here? I see, it's a good question. It's a good question. The question, you know what? Let me finish the second version first, and then I'll come back to that. That one's kind of interesting. The short answer is it's going to be an empty range for the right-hand side. Okay? If, I'll come back there. That's why it was a little bit trickier, which will spend a little bit more time. Okay, yeah. Now, let's talk about the second version. How can we write the second version? Basically, you want to say, if the current index I'm looking at is not the same as I do want to say the old version is the same as the new version. Otherwise, I don't care. There is a logical operator for you to say, if it is the case, I do something, otherwise I don't care. Which operator is that for logic? Is it conjunction, disjunction, negation, or implication? Implication, actually, okay? So let's write it down. Okay, I'm gonna write it here. So now for implication, I'll write down in green. So now we can say for every j, okay? And now for the range of the j, I don't have to be so specific about before or after. I can say just the whole range, that's okay. I'm gonna say 0 less than or equal to j, less than xs dot length over here. It is the case. So now, we want to say if the index happens to be I don't care. If the index happens to be not I want to make sure all the values before and after are the same, right? I can say implication. I'll write it down. So now I can say that if j value is not the same as I, which is what we are trying to change over here, which is already covered by the previous postcondition, right? Okay? That implies the following. That implies xs j is the same as old xs j. And that's the second version. Of course, with the insight that you understand about how implication works. Both are equivalents, okay? For the first one, if you want to translate it into IFO, you might need a disjunction between 2 across, okay, to actually specify 2 ranges. Okay, anyway, the first version is more recommended, but given that you know about the implication, okay, it's really important, okay? Hey, any questions here about this? So both versions. I would say the second version is the one you will want to write in IFO, okay? For the empty range, let me get back to you offline. And if it's worthwhile, I'll talk about it in the class, maybe a little bit later. Yeah.
No,
Another question, yes.
how would you write that in IFO?
Yeah, how would you write this in IFO? Okay. How would you do that? Okay, let's do another one here. For version number 2, how do we write it in IFO? Again, so this we say for every I such that 0 less than or equal to I, less than xs dot length. And then we say that over here, j not equal to I. Sorry, I meant to say j here. J here and j here. J is not equal to I implies xs j is the same as old version of xsj. Okay? How do we write in IFO? You pretty much know everything already, except that you should want to know what's the corresponding operator for implies. It simply implies. Just spell it out. Okay? Let's write it down. This is how you write it. You can say across. Okay, again, how do we specify as an interval? It's going to be from 0 until xs dot length minus 1. Across 0 vertical bar dot dot xs dot length minus 1 and bracket that as as j. Okay? And then now, since we're using universal quantification, so we're going to say all. Okay? And then n over here. Okay? So far, so good. So now it's about translating this part here to be the body for the cross. Okay? We can say now, anyone want to try to be very precise about what you have to write for the antecedents, programmatically?
J.
Just J?
No, J slash equal I.
You say J slash equal I. Okay, I'll write it down first. Okay? Implies, I agree. Okay, that's how you write it, just a keyword. Implies, okay?
Access J equal I.
Oh, that's fine. Everybody agree or anybody disagree? Is this a valid piece of IFO code? Aha, if you write this in the lab test, I'm afraid your code is not going to compile. Okay, but you know, it's okay, it's only the third lecture, right? Hopefully you learned it from today. Okay, now, be careful over here. The I over here is referring to this integer I over here, so we don't have to say cursor, right? We don't have to say the item. However, the J over here is an integer cursor. So you will have something that is a little bit counterintuitive. You know, there's a compromise when you do a programming language. Rather than J, J the item. Rather than J, J the item. Okay? Absolutely. Okay? Yeah, you know, even though we're still discussing Java, but I'm gradually introducing to the most commonly used syntax you have to be aware of. That's the number one mistake you will make when you first use across. Okay, just don't forget. Okay, any question about this? Okay. Oh, I do have another question for you. You know what? Gafu, this would be very similar to the question you just asked. It will be similar, but it's a very worthwhile doing. Guys, I do have a question for you, okay? Let's say this. Let me just write something down here. That's also very important, okay? Let's forget about this example over here, right? Let's say I have something here. Let's say I have a Boolean method or query, let's say all positive. Okay, I have some integer array, xs. Okay, it's guaranteed because of void safety, xs cannot be void, right? So we don't have any precondition. That means empty array is fine. All right? So now, first of all, I'm pretty sure the first step you're able to do it. Let's say ensure, how do we say the result? Result is, let's write IFO directly, shall we? Result will be, what's that? Well, we can use across, right? Across all or across some? All, right? We want to make sure all the numbers are positive, right? Okay, let's try to do it. Okay, I'll write it down and I'll ask you my question. Basically, you can say across. For the moment, let's assume the lower bound is 0, okay? Let's assume. 0 until xs the length -1, okay? S, I, or Okay? And then xsi larger than 0. Yeah, that was intentional. I'm glad you caught it right away. Right? Good. No, that was really intentional. I didn't forget. I was hoping somebody will catch that. Good. 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 Okay. Everybody okay with it? Of course, I'm gonna add another parenthesis. By the way, since you're graduating, try to compile in your mind if possible. Sometimes, right? Okay, good. So now I have a question for you. This is all related to your logic course. Okay? Now, what if I say all positive over here? I'm trying to make a call. Of course, if I say all positive, if I simply give an array, if I say 1, 2, 3, and then -4, for example, I know that it's going to be false, right? Very simple example. Let's see another one. I want to talk about extreme case. What if I say all positive, but I give you an empty array? Don't tell me it's going to crash. It's not going to crash, right? It's not going to crash. Okay, there are two things we can talk about over here. One is about logic, about asserting some universal quantification over an empty collection. That's point number one. Point number two, what happens when you got, let's talk about programming first, okay? And then I'll go to logic, okay? Okay, it's all relevant, okay? Don't worry. I'm not talking about anything that's useless, okay? Now, according to this particular orange call over here, right? So that means we have an interval starting from 0. And what about this expression here? xs.length minus 1. What would that be? -1, right? What is that? You don't know? Okay. Okay, again, let's be a little bit mathematical, okay? Very mathematical. Basically, you learn about closed interval, right? If I have a closed interval, let's say from 1 to 10, how many numbers do I have in this closed interval? 10. How do I calculate that? Basically, it's like a 10 minus 1 plus 1. In general, if you have a closed interval from x to y, how many numbers will be there between x and y? Y minus x plus 1, right? Okay, hopefully you're okay with that, right? Now, let's do exactly the same thing. What will be the size for this particular interval? -1, -0, plus 1, 0. It's equivalent to an empty interval, which means it's not going to crash at the runtime, but rather it's going to give you some value for empty collection for the universal quantification. Okay, that's the first question. That's the first point to note. It is certainly possible for you to have some empty interval like this. It's very common, which means the lower bound is actually larger than the higher bound, the upper bound, okay? Now, second question. When we have a universal quantification over an empty set or collection, what should be the value? True, right? True, right? Okay, you think false. Okay, so let's write it down. Well, it's not really, yeah, well, we could have voted, but it's not really worth doing. Okay, let's do this, okay? Again, that's a review very quickly, very relevant. For every x, such that x is a member of empty set, and then any property over here, I believe for those of you who actually took 10, 20, 30 with me, I might have briefly explained this a little bit in the recursion lecture. But if you forgot, that's okay. Yeah, maybe I did. Okay. So now, this is going to be just true. So what's the idea over here? That's intuitively, that's how you can think of it, because there is no such elements x in empty set that can falsify P of x. So what does that mean? When I ask you if there's any, when I say, okay, let me put the example here so you will see a little bit better. So when I say all positive, and then I say empty array over here, right? So basically thinking in the opposite way, can you find any negative number in the array? Since you cannot, so we know that all the numbers there should be positive. As long as you cannot find any witness that's going to falsify the property, that means the property must be true. Okay? Hopefully that's not something completely new to you, I hope. Okay? Such elements is so-called witness. Okay, something similar, one thing I want to mention once more. What about there exists X such that X is an element of empty set? It is the case P of X. What would that be? False, right? In this case, well, the idea is very similar because you just cannot find any witness in the empty set that can make the property true, right? Make sense? I can repeat it again. I'll write it down. It's going to be false because there is no witness in this particular empty set that can make P of X true. Okay, for example, let's say this. Let me change to a slightly different method, okay? Let me say, rather than all positive, let me say some positive. For example, if I say some positive, let's say I got -2, 3, -4, and then -8, let's say. In this case, that should be true, right? Because there's at least one element that is positive, right? So this would be true. You can think about at least you can find a witness in the collection, right? If you just cannot find any witness, in which case you cannot find any witness for the empty set, of course it will be true. It will be just false, right? So when you say some positive over here, when you just get empty array, it will just be false. Okay, it's kind of symmetric for universal and existential quantification. So universal quantification applied to empty collection will be true because you cannot find any witness to falsify the property. On the other hand, existential quantification on empty collection will be false because you cannot find any witness that can prove it. Okay? These are very handy for this course. Okay? All right. If you're okay with it, let's go back here. Okay, the very original question was really how we specify this postcondition over here, right? Okay, hopefully you see that. Let me just tell you once more. Whenever you're trying to specify the postcondition that involves some array, you want to do two things. Not only that the intended change was there, but also you want to make sure the rest of the array is unchanged. That's how we do it. Okay? And we're going to do more on Wednesday because you got to be more rigorous in some other cases. Guys, any questions? Okay? Yes. Which one? About J. You know, for that one, I'll rather talk offline. That way it may take some time. Try to think in terms of the empty range. It's relevant. Okay? Okay, let's go back to the slides, and then let's talk about postcondition, right? Good. Okay, well, I've talked about many things from this point here, but it's worthwhile. Now, the best we can do in Java, let me show you very quickly Java code, and then we can summarize for the Java side, and then we go to iPhone. Okay, the best we can do to really code up the postcondition in Java is by using some assertion. So now the question for you, okay? If you look at this, let me just go back to this particular version over here. Okay, if you look at this version over here, this is the version where we don't have over here, sorry. So this is the version where we got a wrong implementation. So now, how do we somehow capture the value for the balance before the withdrawal? And also compare that against the value after the withdrawal. How do we do that? Any implementation suggestion here? I'm asking about implementation. How would you implement this? Basically, I will show you code, okay? I want you to amend this particular code such that you can keep two versions of the balance. The version of balance before the withdrawal and the version of the balance after the withdrawal. And then somehow assert the after value is exactly the before value minus the amount, right? How would you do it? Yes. Yeah, you can make a local variable. For example, what I can do is, I will sketch the idea and then we'll see the cleaner code. What I can do is, let's say over here, let's say in the else part, let's say right before this, okay, I can simply just do integer, let's say old balance is exactly equal to this dot balance, right? Okay, so now after this particular line over here, right, you can see that the old balance is still keep the version of the balance before the addition, right? And now what can we do over here? What we can do is we can somehow say assert something over here to say this dot balance, which is already the new version of the attribute, right, versus the old balance. So these are the two values we can try to compare, okay? But this is a manual encoding because you have to declare the local variable yourself. But what if you have so many variables in your program? That means you got to do so many manual encodings. Okay, let's have a look at the code and see that. Okay, this is exactly what I meant. Okay, you can look at the yellow highlight part. So what we have to do over here, we got to say integer old balance. This is right before we try to do the change, right? Right before, okay? For example, let's say initially maybe the balance is simply just 100, the example that we just talked about, right? And then we try to execute this particular line, for example, okay? Apparently this is the right implementation, right? That's correct because we're using minus. And now after this line over here, we are trying to evaluate this particular assertion, right? Is the assertion going to pass in this case? It would, right? Because you can see that this dot get balance over here, okay? This dot get balance, let's say, let me just give you a concrete example. Let's say the balance was 100, and then we are trying to withdraw 50, for example, right? And then after this particular line of implementation, the new balance will be 100 minus 50, which will be 50, right? So that means after this dot balance will just be 50. Let's now evaluate the assertion over here, right? This dot get balance will be 50. O balance is exactly the value that we cached. Okay, I'm going to use this word a lot, cache, which means store that, right? And that one there will be 100. And now amount that we talk about is 50. So now we are really evaluating 50 equals 100 minus 50 will be true. This is okay. But if you change the minus sign to plus sign, in that case you will get a postcondition violation, right? Because over here, in case you are a little bit confused, let's say I change that to plus instead. I still got the original balance being 100. I still got the withdrawal amount to be 50. But now, if I change that to be, let's say, plus, that means this dot balance would be, rather than 50, it's going to be 150, right? So now that means we're evaluating this particular condition being 150, the new amount, the wrong one. It equals, and then the old balance would be still 100 minus 50, right? So that would be false. Okay. So the idea of this particular very simple postcondition here is it's difficult to encode, even though it's doable. Okay. Are we okay with this particular example over here? Okay. I'll give you more systematic introduction about how you can write postcondition, but it's only a first flavor. Okay. Guys, any questions? Okay, if no questions, let me go on a little bit further. Okay, so now let's go back to the slides. Okay, that's version number 5, which will just do the postcondition. Okay. Okay, if you do it, you're gonna have the postcondition violation, right? Okay, let me just see what I have over here on the iPad. Okay. All right, over here, basically, if you actually try to withdraw, which has the wrong implementation, and it's going to give you the assertion violation as expected after adding the postcondition. Okay. Now let's go a little bit further. Okay, so basically we talk about 5 versions. Okay, you can go over all the criticism that we talk about. The main thing is, if you want to implement the side by contract in Java, it's doable. It's just not as convenient as supporting them natively in a language. So that's why we choose IFO for this course as an instruction language. Okay? Especially, we want you to really understand how to write contracts as your design, since the focus is not implementation, but design. Okay? Okay, so that's all the points we have covered. You can just go over them, okay, to get a feel. Okay? Any question about the Java side before I leave the Java? Okay? Sometimes I might still show you, for the particular design in IFO, how do we do it in Java? It still doesn't hurt to talk about Java once in a while. But the main language from now on would be IFO. Okay? Good. After this, okay, you can still look at the table over here to talk about benefits and obligation, which we also talked about the other day, okay, for between the client and supplier. Okay, I'll leave you to that too. Okay, so again, this is the summary of precondition and postcondition invariance, right? Again, I don't need to repeat. Everything has been said. Okay, okay, now let's talk about IFO, okay? So this is basically so now let me just show you one more code. So this is kind of the version 5 you have, final version in Java, where you got old version of the attributes, you got conditions for throw the exception, also you got the assertion over here for postcondition. Right? You got so many things. Okay? Now, what will be the corresponding version in IFO? This is how it looks like. Okay? I'm sure many of you have seen that, but let me just mention that because I want to talk about how contrast will be checked at the runtime, which you really have to know the exact details. Okay? Okay, let's have a look at that. So now this is the IFO code. Okay, let's see over here. So now we have the account class over here. And one thing about syntax over here. In Java, how do we know a method is a constructor? Well, it does not have a return type. And also the name of the method is the same as the class name, right? In IFO, it's done in a different way. Okay? The constructor in IFO can be of any name you choose. However, you must explicitly declare the constructor. Okay? So this is the create clause you have over here. We are saying that I have a feature called make over here. I'm going to use that as the constructor. If you did not have this particular create clause, then there's no way for you to create the objects for this class. Okay? Something to mention. Okay, so we got owner, we got balance over here. Okay, you can see we got require, and we got ensure, right? So nothing complicated, right? And this is the view where you show both the contracts and also the implementation. So this is how we usually say. So the green one over here is the supplier secret, how they actually provide the service, the details. So we say that it is the implementation. Okay, the require and ensure together, we call that a specification. Okay, just don't get confused. All right, and of course, you can also choose to only show the contract view for a particular class, which means you don't really show any supplier secret to the clients, right? So over here, you only see the require, ensure, you don't see any do and body over there. Okay, so there's a two views, contract view. Now, let's talk about how the contract will be monitored automatically in IFO. In the case of Java, you will see quite clearly how things will be checked because it got so many exceptions or assertion checks. But now in IFO, all you see is you got a require here, you got to ensure over here, you also got the invariant over here. But how exactly are these contracts enforced at the runtime, right? That's something I would like to talk about quickly. Okay? And the most precise and complete way to specify these is by using a DFA. Do you know what a DFA is? Yeah, deterministic finite automata or state machine. Okay? We're going to use state machine in quite a few occasions for this course. This is the first one. I just want to make it very precise how exactly things will be checked at the runtime. I want to show you that first. And then later on, we're going to talk about maybe after the reading week, we'll talk about a design pattern called the state pattern, in which case we also have to show some DFA. Okay? So now, let's do the first one here. Okay, I'll go over with you the details. If you look at the diagram on the slide, that's exactly what you will see. Okay? It looks complicated, but it's actually quite sensible. I'll go over together with you with examples. Okay? I wouldn't really run it on IFO Studio. I'll just show you what kind of error you might get, and also I'll show you some snapshot, okay, and see how things happen. So there are three possible errors, three possible violations you might have at the runtime. You may have precondition violation, postcondition violation, or you might have invariant violation, either of the three. Okay? Let's see exactly how things will be checked. Okay? And then we'll give you an example. Okay, good. Let's see how we can start the things. Okay, so now, by the way, can you see which stage should we start with, according to the diagram? Should be here, right? Okay, you can see that's the arrow that has no origin stage, okay, based on the convention, right? Okay, that's where we start. Okay, so now, let's say we try to create an account objects. We say create the accounts, acc.make, and then some accounts, some amount, and also some username. Okay? Now, and then as soon as we try to execute this block of code, we're going to face two branches. Okay? So when we are reaching this particular state, we have two options, right? In the case of the account example, remember over here, I'll show you. We might have a precondition violation, but how is that possible? Okay? Let me show you how this one is possible. Let's have a look at this. Okay? Again, I'm trying to show you all the parties over here. So we got clients over here. We got supplier over here. Okay, let's look at the supplier. Let me tell you which feature you should look at. So we have the account class over here, and then we talk about this particular constructor make, right? That one there has a required precondition, which has a tag positive balance, which should be whatever balance you give should be larger than 0. Okay? So now let's say in the client's code, this is what we do. We simply say -10. -10 larger than 0 will give us false, which means we have some precondition violation, right? Right away, even before you try to create the objects. So in the iPhone Studio, this is what you will see, right? What you will see is, you will see that exactly there will be a breakpoint stopping at the required clause over here. I'm sure many of you have seen this already in your lab, okay? Although I emphasize that. And then you'll see some stack trace over here. It tells you exactly which contract is being violated. In this case, it's a precondition violation, okay? It's called positive balance over here. That means even before you try to create the object, you might already violate the precondition for your constructor. That's the very first one you may run into. Make sense? Okay, that's the very first scenario. Okay, after this, let's go back to the diagram over here. Let's say we give some valid initial balance. Let's say 100, for example, right? So that means we're going to follow this particular path over here. Let's say we follow this path, okay? Let's say the precondition is satisfied. So now we go to a particular state over here, and then we are really going to execute the body of the constructor because the precondition is satisfied, okay? So now what we will do is, let me highlight it. So we're gonna execute this particular, okay? We're going to execute this particular constructor over here, which is going to set, for example, you can set, let's say the initial balance is 100, and the name is maybe A. For example, set them up together, okay? So now, what we might have issue would be, let's say after this particular call to the constructor, okay, or any method call in general, at the end of your method call, you want to make sure you satisfy the contract that constrains the supplier, right? For example, if you try to do withdrawal, you want to make sure you really try to subtract the amount rather than adding to it, right? That's one example, okay? So now, at the end of your constructor over here, you might check to see if everything has been set properly, right? If you go back to the code over here, you can see at the moment we don't really have any ensure over here, but maybe we can put it. But I'm just saying at the moment we don't have any ensure, okay? But I'll give you another example in just a moment for postcondition. Okay? So now let's say if the postcondition is violated, you might get postcondition violation. Otherwise, where would you go? Okay, I'm also going to give you a green. So that means after we try to execute the body of the constructor, we're going to create the objects, and then we're going to go this way over here. We're going to go to another state over here where we're going to make sure whatever objects you might create must satisfy the invariance. You can think about what we said before. Invariant is like the postcondition for every method, which means at the end of every method, you want to make sure the integrity for the object is not compromised, right? So now, let's say over here, what's the invariance for this class over here? You can see for the account, it's balance larger than 0. Okay, it is that. Okay, so now, if you try to give some negative balance, well, it would be caught as a precondition violation, but I will show you another scenario in just a moment. Okay, okay, let's say we got 100 over here, so that means 100 larger than 0 will satisfy the initial invariant. That is okay. Okay, so now that means we're going to go to this particular state over here, and now that means we are now safe. Safe in the sense that we satisfy the initial precondition for the constructor, we execute the body of implementation for the constructor, and we also satisfy the invariance. That's what we have so far. And now, let's try to call some method over here, okay, and see what happened. Let's say we are trying to call ACC, the method which, the object we just created, and say withdraw. So what's going to happen when we say withdraw, right? So we got the various preconditions for the withdrawal. We also got some postcondition for the withdrawal. We still have the class invariant to be checked, right? So what should be the order of checking them? Okay, that's kind of the example I want to go through quickly. Okay, if you look at the withdrawal over here, how many preconditions do we have? You got one here, you got another one here. Okay, we also have a postcondition for the withdrawal. Okay, so conceptually, that's how you can think of it. Before I try to execute a particular method or feature, I want to check all its precondition, one by one. And then execute the body of that particular feature. At the end of the feature, what would I do? First, I check to see if all the postconditions are satisfied for that particular feature. And then I'll check to see if the invariance for that particular class is satisfied. Only all these contracts can be satisfied, can I move on to the next safe states. Okay, that's kind of the idea. Okay, let's go over the diagram and I'll show you more examples. Okay, let's see this. Let's say I try to, let's say, call this particular withdrawal. Okay, I might have some precondition violation. Let's see how exactly. I'll give you 2 examples. Okay, let's see 2 examples over here. Okay, example maybe just one. Yeah, example number 1. Okay, the one I want you to focus on will be this. So now I want you to look at this particular precondition for withdrawal. The amount we are trying to withdraw must be larger than or equal to 0. Let's say that's what we have, right? In that case, if you're trying to create an account and then you're trying to withdraw something that's negative, right? So that means this particular expression is going to be false. That's how you get into the precondition violation, right? You will have some non-negative amount violation. And for those of you who actually followed the tutorial video for Lab 0, remember there's a feature called add violation with tag, right? So that feature there is exactly for this purpose. We want, sometimes when you want to test for your code, not just they want to test for just the code correctness. You want to see if all your contracts can be violated when they should be violated. In that case, that's where the tag can be useful. Okay? I'll leave you to the tutorial video. Okay? It's already set in detail. Okay, that's the particular precondition violation we have. That's case number 1. Okay? Where it's simply just negative. Let's do another one over here. Let's say we talk about this particular precondition here. If you try to give the amount should be less than or equal to balance, which means it should be affordable, right? Let's say you initialize 100, but you're trying to withdraw 150. Well, apparently, you can see 150 less than or equal to 100 will give you false. Okay, that's another precondition violation. Okay, right? That's another one. But now you can see it's a different tag over here. Okay, if you look at the call stack, it's going to be a different tag over here. Good. Guys, are we okay so far? Okay, yeah. All right, after this, let's see what happened. Okay, let's say we talk about a precondition. Let me just go on. Okay, after the precondition, we're going to execute the body of the method over here. So now, what's going to be checked at the end of the method? We're going to check to see if the postcondition is satisfied, and also if the invariant for the class is also maintained, right? So these are the 2 things we want to check. Okay? So now, I'm just going to show you on the diagram. You can read those two examples by yourself. The similar idea. Okay. Okay. So now you can see that at the end of the method execution, we might either have a postcondition violation over here. Okay. Let's say the withdraw use plus rather than minus, right? That can cause a postcondition violation. You can see that on the notes. Okay. Otherwise, we can actually just go over to actually check another thing, which will be the invariance, right? So now you can see after this, after we go back there, we still want to make sure that the balance after the withdrawal is still positive, right? Only after that we can go back to the safe states again. So this is safe states. Okay. Anyway, it's kind of a complicated, but I think it's necessary for you to really understand how exactly things will be checked at runtime. I'll only talk about it once, so hopefully you can apply that to your lab, okay? Especially for debugging. Any question about the diagram over here? Okay, right? Good. Yeah, it's kind of a fast, but hopefully if you almost fall asleep, watch the recording when you go home, right? Maybe they'll help you sleep even better. Right? Yeah, that's why I want to speed out a little bit. I know it's kind of boring, but gotta cover that. Okay, let's now, okay, I tell you what my plan is. On Wednesday, I have to start with our first topic about how to write complete postcondition, for sure. But now, between now and 2:20, maybe about 10 or 15 minutes, what I will do, I'll refer you to maybe 2 slides over here. They are for your reference. I'll try to go over as much as possible, just a survival guide for writing iPhone. Yeah, I'll just choose the most important ones. Now for the rest, you can just go over by yourself. Okay? And you can go over the rest of the slides. Let me just, I already posted online. You can also look at that. So there are 2 sets of slides I made for you. Okay? It's mainly for you to really have a quick look. There are not really that many. You just can go over them quickly. May not help lab number 1 immediately, but maybe future labs. One is about how you can, the common syntax for iPhone. Okay? The other one is about the common errors you can make in iPhone. There will be some errors which I will come back to there once we talk about the corresponding concept. Okay, but so now what I want to do, I'll go over things very quickly. There are certain things I can talk about quickly, just to remind you, right? One of the things you will see in the syntax is across, which we cover quite a bit today already, right? Okay, let's go. This one here. Okay, escape sequence. Don't need to bother you with that. Just know how to do a percentage sign rather than / in iPhone. Okay, so here in Java, we got attributes, mutators, accessors. But now I'll try to, at least for myself, I'm going to mention things like a feature. Right? Features like a method in in Java. And then if you want to say, we'll say attributes, command, and also queries. Command is something that does not return anything. Query is something that returns something. Okay. Oh, sorry. Query is a feature that returns something. Yeah. Okay. Okay, good. Naming convention. Okay, you can read it through. I don't need to bother you with that. I tell you what, naming convention, every programming language has their own naming convention. You follow that just for the sake of your colleagues who also program in that language. So you got a same convention, okay? But you wouldn't be enforced. Okay, so now this is something I want to talk about. You might be wondering why. Okay, may not be very useful to your lab, but I do want to talk about it. It's more like a language design choice. If you think about it, in your life, the first time you see this sign over here, what does it really mean? In the very first time you saw this sign. Equals, mathematical equality, right? Right? Not really assigned to, which means it's only when you saw Java the first time that it will actually pollute your mind by saying that should be something that's assigned to. Okay? So it's a language choice, So now, this is math, just mean equality, okay? That means iPhone, they simply say, we don't want to say equals means assigned to. Equals simply means equality, like how you do in math. But now we want to choose another operator for assignments. Calling equal. It's a language design choice, okay? Okay, that's the only thing I want to talk about. Okay, decide by contract view, okay. And for every, by the way, there's another common mistake I just noticed from the other day's lab. When you say feature, you don't say feature and. You don't need to end a feature, just feature. Okay, if you do another n, that will be a compile time error. Okay. Okay, you can also go over them. Okay. Oh, there's another thing that's interesting. A very common error for you to make is also like this. Let's say I have a query which returns an integer. Very common mistake is like this. You say local something, local variables, and then you say require. Precondition, and then you say do, and then you say end. Of course, you might say ensure. Should this compile this structure here? For those of you who are into IFO already, do you think this might compile, this sequence here? No, what's wrong here? No, nothing to do. Let's say we do the dot 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 means we do something that's valid. Valid for local variable declaration, valid for precondition specification, But the way we order these stuff, do you think they're in the right order? Aha, okay, it's a very subtle thing, but I'll try to explain how I understand it to you, okay? So, over here, this will not compile because local is supposed to go after require. You should say require first, and then local if necessary, and then do. This is how I understand it, okay? You can think about require is basically the obligation for the client to satisfy, right? It's only when the client's obligation is satisfied are we, the supplier, going to consider our implementation. And local is simply part of the implementation, which means given that require is satisfied, we're going to say local and do. So this part here will be the implementation. And then after that, we do the ensure, the postcondition. So that would be the logical order. Okay? Again, it's a language choice, design choice. Okay, anything else? Okay, that's something we just talked about, right? The diagram. Okay, so we got about 5 to 10 minutes. Okay, I'll make sure I'll dismiss you in time. Okay, over here, just make sure, I tell you what, for this part over here, exactly, do me a favor. Only review this slide, 43, before Wednesday's lecture. Okay, this one is really about how we can actually somehow check the postcondition, but in a very informal way. We're going to talk about it in a formal way, maybe a little bit more on Wednesday. Okay, you can go over that. It's about how you check the contracts. Okay, so that's about violation. Okay, we have covered them already, so don't worry. Let me see if any more syntax. Am I actually looking at I'm looking at the wrong slides, no wonder. Okay, attribute declaration over here. Okay, so now another syntax to show you over here. I want to make sure. So now in Java, you say integer I, right? That's what you do in Java. But in IFO, you do it this way. I colon integer. There's a reason for that, okay? This sign over here denotes this symbol over here. What does this symbol mean? Set membership, okay? So this is how you can think of it. When I declare I to be of type integer, that means at the runtime, I can be any value that is a member of the set of integers. That's exactly how you understand what a data type is. Okay? Hopefully that will help you understand. Yeah?
Just a little personal. Where do you have if I equals 5? How would you do that at 9?
Oh, int I equals 5. Good question. So in Java, you might say integer I is initialized to be 5 over here, right? In IFO, I'm afraid you cannot do it. The declaration and the assignments has to be separate. So how would you do it? Okay, if that's Java here, how would you do it in IFO? You gotta do something like, so under local declaration, you gotta say I is a member of integer. And then maybe inside your do and body over here, you will say I is assigned to 5. I'm afraid that's the only way you can do it. It's good that you ask. Okay. Okay, attribute declaration, that's how you declare commands and also query. Okay, similar idea. When you say a query returns an integer, that means the return value is simply a member of the set of integers. The same idea. So where the colon there means a member of. Okay, 5 more minutes. Okay. Okay, now logical operators. Okay, this is the interesting bit. Let me just talk about it quickly, okay? This might take 5 minutes, but that's okay. Logical operators. And for the rest, you can just go over them by yourself. Maybe in the due time, maybe I'll also go over them together with you. Okay, that's the last topic for today. Let's talk about logic. When you talk about logic, you got P conjunction conjoined with Q, P or Q, also not P, right? Conjunction, disjunction, and also P implies Q. It's like, okay, let's just focus on these three. That's a logic. Okay? So now let's talk about Java. Since you should know Java very well, right? Specifically, if I have some Boolean condition, let's say B, let's say also P, ampersand, ampersand, and Q. P, vertical bar, Q. So now, my question for you, specifically, P and Q over here, mathematically speaking, conjunction. P and Q looks like conjunction. Are they completely equivalent? Try, yes.
So Java's short circuit validation
Ah,
is evaluated false and it does a boundary check with Q.
wow, that's amazing. Guys, what Ken just mentioned is something called short circuit evaluation. Does it ring the bell somehow? Short circuit? So what does short circuit really means? You want to try? What's short circuit? What you forget? You. Yeah, sorry, I don't know your name, so that's okay, yeah. Okay, short circuit means the following way. Okay, I'll mention that briefly. Okay, we know that for conjunction over here, okay, so you got P and Q, true, 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 false, false, true, and false, false. You got P and Q, right? The only way to make P and Q true is when both of them are true, right? Otherwise, it will be false for all the cases. So now, when you evaluate P and Q at the runtime, they do some trick for you. Here's the following. If it's going to evaluate from left to right, evaluation left to right, it's going to evaluate P first. If P is already known to be false, do we have to bother evaluating the right-hand side? No, it's guaranteed to be false overall anyway, right? It's called short circuit evaluation. But in the case of logic, you cannot avoid. You got to evaluate P, evaluate Q, and combine them together. So what would be the application for short circuit? Okay, I'm almost there. Okay, for short circuit, I'll give you one example, very common example. Let's say I want to do a Boolean expression. I can say, let's say I have some feature f over here. Let's say integer I, and then I have, let's say I is fine. Integer array, and then I would say xs. It's going to return some integer, which means I'm giving the index value I. I want to know what's the corresponding value at the index in the array. How do I specify it's a single predicate? Okay. So now I want to say that something like this. I want to say require. I can say I less than. I can say 0 less than or equal to I, and for example, I less than xs.length. Let's say I want to add another thing to the precondition. I want to say not only that, also that particular element there in the array must be positive. Okay, it's actually 3 conjuncts over here, right? Are we okay with this? So now let me ask you this, okay? And then I will continue from here on Wednesday. Let me pose the question to you. I can tell you that this is going to work. However, what if I do the following? I say 0 less than or equal to I, and xs I larger than 0, and I less than xs dot length. Logically speaking, let's say this is P, this is Q, and this is R. right? I'm flipping the order. So this is still the P, and this is R and Q. Logically speaking, P and Q and R should be the same as P and R and Q. Agree? The commutativity for conjunction. Now, for Java program, are they equivalent? I heard no. Okay, I will continue with this example with a little bit more detail, and then we'll talk about other things. Okay, see you.